Welcome to the video on probability distribution. So we will look at different probability distributions here in this video, and we look at their applications part when we go on to machine learning and model building. But right now we'll just look at what these different distributions are. So we'll start with the normal distribution, which is also known as Gaussian distribution. So when normally distributed data is plotted, it follows a bell curve. Bell curve is like this. So this is the curve it follows. We'll see those different plots in the future next slides. So this bell curve, which is basically the result of normally distributed data, uh, is symmetric about the mean. So and the area under the curve is 1. So data points are more dense near the mean, which is the central part of the curve, the middle part of the curve, and those which are far from the mean, they are not so dense. And it is a probability distribution, so also known as Gaussian distribution. The two controlling factors or the parameters in a normal distribution curve are mean of the data, which determines the center of the curve, and standard deviation, which determines the height and width of the curve. So if the larger the value of SD, the shorter and wider will be the curve. If the value of SD is small, that is standard deviation is small, then the curve will be narrow and tall. So we'll look at the equation. Basically, this is the equation of the curve fx. X is the value data points, and 1 upon sigma into square root of 2 pi. Sigma is basically standard deviation. The whole thing is multiplied by the exponential of minus x minus mu whole square by 2 sigma square. Now mu is mean and sigma is standard deviation. And as you know, standard deviation is square root of variance. So sigma square is basically variance. This is the formula. So a lot of real world data follow normal distribution, and normal distribution can be very useful in explaining a lot of things in the data. So if we take the averages of independent and identically distributed random variables, they usually tend to follow normal distribution. So we look at different examples of normal distribution curve. So first example where mean is 100 and standard deviation is 10. So you see this is the curve I was talking about in the previous slide. This is the bell curve it follows. See, and mean is at the center. So mean decides the center part of the curve, which is 100 here, and standard deviation. So it is moving in both the direction by 1 standard deviation. So in negative side it is 100 minus 10 is 90, 100 plus 10 is 110, and then it goes on like this in the positive side, and the right side is positive and left side is negative. Then another example is where it's called standard normal distribution, because mean is 0 and standard deviation is 1. So whenever mean is 0 and standard deviation is 1 in normal distribution, it becomes standard normal distribution, and the curve will be standard normal curve. And then we look at the effect of changing the standard deviation on the curve. So although we are keeping the mean same 0, so mean is 0 for both the curves, both the distributions, but the standard deviation is different. So this is where the standard deviation is 1. So you see it is quite narrow and tall. When we increase the standard deviation by 1, it becomes short and also wide. This is what we are talking about in the previous video. Now we'll look at the effect of changing the mean on normal distribution curves. So we have kept the standard deviation as 1 for both. So you see, but we have changed the mean. So when we change the mean, the only thing that happens is the curve shifts. So the first one mean is 0 here. So and we increase the mean by 5 for the next curve or distribution. So it has just shifted to the right. That's all. Otherwise, the shape remains the same. The height and width remain the same. This is all. So these are the few examples to understand how normal distribution curve is plotted, and how the distribution looks like. Now we look at what is the meaning of area under this bell curve or the normal distribution curve. So we are taking the example of mean as 100 and standard deviation as 10. So this is the curve. So mean is 100 and standard deviation is 10. So it's moving by one standard deviation both sides. And we have taken a value, basically plotted, this area. We have darkened this area, uh, which is from mean to 100, mean which is 100 and 105. So this we have this area. So what does this area mean actually? This area means the probability of finding the value x between 100 and 105. This is what this area under the curve means. So now let's look at the relationship between normal curve, distribution curve, and standard deviation. So we are plotting normal distribution curve with mean 0 and standard deviation 1. So this is the first example. So what happens is 68% of the area of this curve falls within one standard deviation from the mean. So you see, since standard deviation is 1 and mean is 0, so mean is 0, and so minus 1 to 1. So in the left side it is minus 1 SD and the right side plus 1 SD. So within these two, whatever area we cover, that covers 68%. So the probability of finding the value is in this area is 68%. Now this is when we cover the area within two standard deviation on both the sides, left side and right side. So this is minus 2 SD and this is plus 2 SD from mean. So whatever area we cover under this curve, that gives the probability of finding the value. So that, and what is that probability? 95%. So 95% is the probability of finding the value x within 2 SD from the mean in under this normal distribution curve. And then same goes with 3 SD. So 3 on the both the sides. So minus 3 SD to plus 3 SD within from the mean. So there the probability of finding the value x is 99.7%. We'll also explain this through one example here. So let's say the mean salary is 100 and standard deviation is 10 of the employees. So what it means is the 68% of the salary will fall within one standard deviation. What it means is 1 minus 1 SD to plus 1 SD from mean. So minus 1 SD is 90 and plus 1 SD is 100 from the mean, right? 110, right? So 100 minus 10 is 90, 100 plus 10 is 110. So 68% of the salary or the value of the salary will be found within one standard deviation from the mean. That's what it means. Now the 95% of the values of salary will be found within two standard deviations. So 2 into 10 is 20. So 100 minus 20 is 80. 100 plus 20 is 120. So this is what it means, that 95% of the salaries will be present within 2 SD from the mean. And then 99.7% of the salary would fall within 3 SD. That means 3 standard deviation. So 3 into 10 is 30. 100 minus 30 is 70. 100 plus 30 is 130. So 99.7% of the salaries will be present within these two. The probability of finding them is 99.7% within 70 and 130. That's what it means. Now we'll go to chi-square. This is another distribution. So what we saw earlier is normal distribution and standard normal distribution. Now what is chi-square distribution? It is also a kind of distribution in statistics. Both are statistical tools, and they have their own use depending on the kind of data we are dealing with, distribution we are dealing with. And then so both are used for hypothesis test and also explaining the data distribution. So chi-square distribution is basically, it is a continuous probability distribution, and the shape is determined by its degree of freedom. We'll see what degree of freedom is. And but it is when we are dealing with the chi-square distribution can be used for both the continuous or numerical variables as well as for categorical variable. This is the flexibility that chi-square gives us. So right now we are explaining here the chi-square distribution for numerical variables. So but it is very rare to find a real world data which follows chi-square distribution. So the main purpose of this chi-square distribution, main use of this chi-square distribution is for the hypothesis test as a statistical tool. So what is chi-square degree of freedom? Suppose we want to define chi-square with 1 degree of freedom, which is nothing but if we take the square of a standard normal distribution. Now standard normal distribution is represented as n in the bracket 0 and 1. 0 means mean is 0 and standard deviation is 1. So if we take the square of such standard normal distribution, this gives us a chi-square distribution with 1 degree of freedom. Now let's say there are k independent standard normal distributions, different distributions. They are all independent and they are all standard normal distributions. So if we take the square of each independent standard normal distribution and sum them up, what we get is chi-square with k degree of freedom. So one standard, the square of one standard of degree of standard normal distribution gives us a chi-square distribution with 1 degree of freedom. So if we take k such standard normal distribution, square them and sum them up, we'll get a chi-square with k degree of freedom. So the above chi-square square's degree of freedom is k, right? So this chi-square has k degrees of freedom. Now the mean of chi-square is its degree of freedom basically. That's what degree of freedom here is. So the mean of chi-square is its degree of freedom. Another way you can say the degree of freedom chi-square is its mean. And what is variance? Variance is twice the degree of freedom. So 2k becomes variance of the chi-square distribution. Now we'll also look at the equation of chi-square for categorical variable. So let's look at the equation here. So this is sigma summation basically O minus E whole square by E. So what it means is basically here O is the observed frequency and E is the expected frequency. That means in a categorical variable, there let's say there are different groups like A, B, C, D, E, F, whatever, and each group has a different count. So whatever the count in the observed data of each group is called observed frequency. And what were we expecting? Let's say as per our expectations, so there is a assumption that a particular group should have this count, like A should have been 200, group B should have been 300, or whatever we are following, whatever rules we are following. So that becomes our expected frequency. So this is the formula O minus E, sum of O minus E to is the whole square upon E. So we take the square of O basically observed frequency minus expected frequency and take the square of that, divide it by the expected frequency and take the sum of all the values for all the groups. So chi-square distribution plot. So let's look at this plot is for basically for continuous variable. So like as we discussed, the if you take the square of standard normal distribution, that gives us chi-square distribution with 1 degree of freedom, right? So we have taken multiple degrees of freedom. That means this blue one has only 1 degree of freedom. That means it is the square of one standard normal distribution. K is equal to 5 means that there are 5 independent standard normal distributions and they have been squared and summed. So then we are getting this chi-square distribution. If we take K as 10, that means 10 degrees of freedom. That means we have taken 10 different standard normal distribution, squared them and summed them up. Then we are getting this chi-square plot. As we see, the more the degrees of freedom, the flattened it becomes. So less the degree of freedom, it becomes more taller. And although there is a skewness in chi-square distribution, and we have discussed skewness in the previous video, right? So this is like right skewed, right? So both all these curves. So this is what chi-square is all about. Their applications we will see when we go to model building, when we are looking at the each variable, and that's when we know there are different rules to be followed for linear regression and classification model building and stuff. So that's where we need to look at different conditions that variables need to satisfy. And there are different statistical tools also which we use while building a model to see whether our model is performing well or not. So we'll go into details later once we move on to building models, machine learning and stuff. So thank you so much. If you like this video, I'm sure uh, I think it has helped you a bit in improving your knowledge on in data science and statistics. Although it's a very brief introduction, but as we do more and more practice and we build more and more models, we get used to these tools and how they work and how to use them. So thank you again, and please like, share, and subscribe.